Hi guys, this is Miss Scott here. So what we're going to talk about today is the fourth type of conic section called hyperbolas. And you get a hyperbola if you would take a vertical slice through a cone. It actually comes up with these two parabola looking shapes. So the definition of hyperbola is just all points such that the difference of the distances from those points to two fixed points called the foci is constant. And the foci are always outside the hyperbola, so they're like inside the curves of the hyperbola. And just so you guys know, the foci are always on the what we call the transverse axis, and the vertices are also on the transverse axis. So that's just some of the main ideas about hyperbolas. What we're going to learn how to do today is both graph and write equations for these things. So if you look in this table down below, there's some useful information in here. A few things that I want to point out about the info you've got here is that these equations are very similar to ellipses, but there are some key differences. First of all, A is always first, and it doesn't necessarily need to be bigger than B. So A is always first, and unlike ellipses, and it doesn't need to be bigger than B. And that's one of the main differences between hyperbolas and ellipses. Alright. Another key thing that you guys need to be aware of is that these equations even look very similar to equations for ellipses. But it is minus instead of plus. So instead of adding the two terms, you subtract one from the other. And these things called the asymptotes are, if you look in those two pictures above, those are these red dashed lines that you see in the pictures. So these are always linear equations, and they make just lines. So these are the dotted lines in the pictures above. And the last thing is how you find those foci. Again, that's also very similar to ellipses. But now it is plus, so we do addition instead of subtraction. Alright, so the first thing that we're going to do is learn how to get these equations into standard form. So they look something like the equations that you see here. Alright, so we've got these steps here. The first is always get the constant term on one side of the equal sign. Well, you can see that's already the case in example 1. So now we can just divide each side by the constant term. In this case, our constant term is 81. So we're going to divide all terms by that. So we end up with y squared over 81. And you can see here 81 over 81, that's going to reduce down to x squared over 1. And now it equals 1. You always have to have equals 1 for the equation to be in standard form. Alright, example 2 is going to be a little more work because we do need to move this constant term to the other side of the equal sign. So we're going to add 100 to both sides. Then we end up with 25y squared minus 4x squared equals 100. Now that's our constant term, so we need to divide each piece by 100. And then we just simplify the fractions. So 25 hundredths is the same as a quarter, so we simplify this down to y squared over 4. 4 100ths is the same as 1 25th, so we'll simplify this down to x squared over 25, and now that equals 1. We have our equation in standard form. Okay, so now let's look at actually figuring out where the vertices and the foci are if we have an equation of an ellipse, or sorry, of a hyperbola. Okay, so that's example 3. This equation should look pretty familiar. Notice if we divide each term by the constant, we end up with y squared over 4 minus x squared over 25 equals 1. So that's the same equation from example 2. So remember, big thing here, a is always first. So in this case, our a is 2, because 2 squared would give us 4. B is always second, so in this case b is 5, because 5 squared would give us 25. And if you notice here, since you have y squared first, so that's the first term in your equation for your hyperbola, so y squared is first, that actually tells you that the hyperbola is a vertical hyperbola, because that y squared is going to make things go in the y direction, hence vertical. So all you really need to do is, now that you know your a and your b, well, the vertices are always at a. And since this is vertical, your vertices are going to be at 0, positive or negative 2. So you just use that a value. All right, so there's one part. Now to find the foci, those are still going to be on the same axis as the vertices, but we have to use this equation. C squared equals a squared plus b squared. And we're trying to find c, so if we plug in 2 squared, that's 4. If we plug in b squared, that's 25. And we end up with c squared equals 29. And if we take the square root, c will be approximately 5.4. So our foci are at 0, positive or negative 5.4. Okay, so in our next example, we're going to both find this information and graph it. Right, so taking a look at graphing a hyperbola, the first step is just to get your equation in standard form. So you can see here that we need to divide every term by 144. All right, and we can simplify that down. 9 and 144 are both divisible by 9, so this will reduce down to x squared over 16, and that's if you just divide this whole first fraction by 9. If you divide that next fraction by 16, you end up with y squared over 9. We get that by dividing the numerator and denominator here by 16, and 144 divided by 144 is 1. So now we see our a value is 4, and our b value is 3. So just the square root of those denominators. Now in this case, since x squared is first, well, that's going to make this a horizontal. Alright, because it's going to make things go in the x direction, which makes it a horizontal hyperbola. Alright, so we've actually already got where our vertices are. So we're actually on step 2. We identified a and b, and we figured out that this is a horizontal hyperbola. Now we're actually just going to plot the vertices. So our vertices are always coming from that value for a. In this case, it's going to be positive or negative 4, 0. So we go right 4, there's one vertex, and left 4, there's the other. Okay, now is kind of the interesting part here. What you need to do is draw a rectangle that's 2a by 2b. So we go left 4, right 4, we already did that. But then we're also going to use this b value to go up 3 and down 3. We're going to draw in this rectangle here. Oh, I should have gone down 1 more. We have to go down 3. All right. So that rectangle is actually going to give you your asymptotes. So the two asymptotes are going to go through opposite corners of that rectangle, and I usually just use dotted lines to draw those. Those are kind of like your guidelines for drawing your hyperbola. So we're just drawing a dashed line through the opposite corners of the rectangle we drew. And then you finally draw the hyperbola. So your hyperbola is going to just skim those foci, or those vertices on the left and right, and it's never going to go past these dashed lines. So it's going to get closer and closer to them, but never actually cross. Right? So those are kind of like where the hyperbola have to stay inside of those asymptotes. Okay, it's going to get closer and closer to them, but never actually go through. Okay, one last thing is I always like to just find the foci just to make sure that my hyperbola is looking how it should. So my foci, remember we can find by using c squared equals a squared plus b squared. And we've got our a squared and b squared would be 16. And 3 squared would give us 9. So c squared is 25, giving us c would have to be 5. So our foci are going to be at positive or negative 5, 0. And we can see that that would be this point here, be one foci, or one focus, and the other is here. So they do end up inside of those curves of the hyperbola. All right, lastly, we're going to work backwards. So in this equation, or in this example, we know where the vertices and the foci are, and we're going to use that info to find what equation goes with that information. Well, the vertices always give you A, and the foci always give you C. And now I know that this actually also tells us another piece of information, that this hyperbola is vertical, because these A's and C's are in the Y position. So at some point I'm going to fill into this equation, y squared over a squared minus x squared over b squared is equal to 1. We actually already know a. It's 8. Now we just have to find b. Well, we can use this equation, c squared equals a squared plus b squared. We know c is 9. We know a is 8, and we can use this to solve for b. So solving gives us 81 equals 64 plus b squared. We subtract this 64 from both sides. These will cancel, and we end up with 17 equals b squared. All right, so we are just about done. Let's plug in what we know. So y squared over 8 squared minus x squared, and then b squared is actually just 17. So I'm just going to replace it right away. And then lastly, let's go ahead and actually square that 8. So we end up with y squared over 64 minus x squared over 17 equals 1. All right, well, thank you guys for watching. There is an assignment on 10.5. Feel free to watch this video again if you didn't quite get what we needed out of this. So if you have questions, let me know, and you can start working on today's assignment.